We are discussing the in-text questions given in your textbook in page number 297. The first one, 10.2. Why is sulfuric acid not used during the reaction of alcohols with potassium iodide? So this is related actually to the various methods of preparation of haloalkanes from alcohols. In that, you actually have a sentence saying that good yields of Ri may be obtained by heating alcohols with sodium or potassium iodide in 95% orthophosphoric acid. So the question over here is, why are we not using sulfuric acid instead of orthophosphoric acid? So when you have sulfuric acid, what happens is the potassium iodide reacts with sulfuric acid to give us KHSO4 plus Hi. And to balance this equation, we'll have to add 2 in front of that. And this hydrogen iodide actually could probably react with the alcohol. But what the sulfuric acid does is react with this hydrogen iodide again, and 2Hi plus H2SO4 gives rise to H2O plus I2 plus SO2. And because it's undergoing these chemical reactions in the presence of sulfuric acid, we cannot use sulfuric acid for the as one of the reagents in this chemical reaction where we have alcohols getting converted to haloalkanes. Instead, we use orthophosphoric acid, which is considered to be slightly, it's a non-oxidizing acid, and so it will basically not lead to such reactions taking place, and in turn not lead to stop the reactions. Also, the iodine which is formed here cannot react with the alcohol to lead to the formation of the iodoalkane, and because of that, sulfuric acid is not used. The next one, write the structures of various dihalogen derivatives of propane. So, when you have propane, let's write the structure of propane first. CH3, CH2, CH3. So first one is, okay, we're going to number this. Okay, the first one is when a chlorine atom, I'm taking chlorine. Okay, so chlorine is attached to the first and the third carbon. So Cl, CH3, CH2, CH2. Oh, sorry. Cl, CH2, 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 Cl. So 1, 2, 3, 1, 3 dichloropropane. Okay, the next one, you have it attached to the first and the second carbon atom. So that is CH2, Cl, CH, Cl, CH3. So 1, 2 and 3, 1, 2 dichloropropane. Now we are not now we'll not be considering 2 and 3, because if it was the second and the third, then automatically this carbon would get numbered as 1, 2 and 3, and the name of the compound would be 1,2-dichloropropane. So we're not considering that. Next, we're considering when both of the chlorine atoms are attached to the same carbon. So let's start with the first one. So CH, Cl, Cl, CH2, CH3. So 1, 2 and 3. So 1, 1 dichloropropane. Now remember, even if it's not like a part of this question, I'm making a point to write the IUPAC name, because writing the IUPAC name is in itself very good practice. So, feel free to just practice it as and when possible. And the last one is when both the chlorine atoms are attached to the second carbon. So CH3, C, Cl, Cl, CH3. So 2, 2 dichloropropane. That's it. And the last one, 10.4 for this video. We have another one which will be discussed in the next video, that is 10.4. Amongst the isomeric alkanes of molecular formula C5H12, identify the one that on photochemical chlorination yields a single monochloride, 3 isomeric monochlorides, and 4 isomeric monochlorides. So there were ways I was thinking of explaining this question, but somehow I felt this is probably the easiest way for you to understand. And if you don't, feel free to reach out and let me know and tell me how I can make it better. So first what we're going to do is we are going to write the various isomers of the molecular formula C5H12. Let's start from there and then figure out which will yield a single monochloride, which one will yield 3, and which one will yield 4. Okay, so C5H12. The first one is obviously going to be a straight chain, that is CH3, CH2, 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 CH3. This is the first one. The second one is if it could be 4 carbon atoms long. So that is CH3, CH, CH3, CH2, CH3. And then we'll shorten it by another carbon. So CH3, C, CH3, CH3, and CH3. Now these are the various isomers of pentane basically. Now we need to figure out which of these will yield a single monochloride. Now look at the various various isomers that are formed. Okay, now when we talk about IUPAC nomenclature, right, if this, or this, either of the 4 hydrogens were replaced by a chlorine, they would have the exact same name. So essentially they're the same. So this particular molecule, that is 2,2 dimethyl propane, is going to yield just 1 monochloride. If you want, we will, you know what we're going to do? We're going to write all the structures possible. So CH2, Cl, C, CH3, CH3, CH3. So the main chain obviously is going to be this, right, because it has the chlorine, right? So that's the main chain that is present. So you have the first carbon atom having the chlorine, so 1 chloro, 2,2 dimethyl propane. Right. Now, let's assume one of these are replaced by one of the hydrogen atoms for this carbon atom has been replaced by a chlorine. So CH, Cl, C, CH3, 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 CH2Cl, sorry. Now, in this case, I can assume our main chain to be these 3 carbons, or these 3, or even these 3 carbons. It's fine. Either way, this is our second. So we are assuming it's this straight chain. Okay. So again, the name of the compound. This is the first carbon, this is second, this is the third. So 1 chloro, 2,2 dimethyl propane. And that is why this one, 2,2 dimethyl propane, is going to yield a single monochloride. So this is the answer to the first one. Now the next one over here. Okay, let's look at what are the possible isomers that it can give us. Monochloro substituted. Okay, I'm just going to quickly erase this one over here. Now, right. Now, if you remember, this is basically what we looked at in the example problem. Okay, so we'd gotten 4 isomers, that is CH2, Cl. I'll put the link, or I'll put the video on the banner and the link in the description below. But it's essentially, this is the first one. Okay, first carbon. The second carbon, that is CH3, C, CH3, Cl, CH2, CH3. That is the second one. The third one, third carbon atom, hydrogen is getting replaced by chlorine. So CH3, CH, CH, Cl, CH3. This is the third one. The fourth one is this carbon atom. So CH3, CH, CH3, CH2, CH2, Cl. So it's giving us 4 isomers. So this particular molecule, that is 2-methyl butane, is giving us 4 isomeric monochlorides. So this is the answer to the third one. Okay, the last one is this. Obviously, it's going to give us 3 isomeric monochlorides, but I'm going to draw the structures for the same. So the thing is, let's number these 1, 2, 3, 4, and 5. And 1, 2, 3, 4, 5. So the reason I've numbered it from left to right and right to left is, if you, let's say this carbon atom had a chlorine atom attached to it, okay, it would be called 1-chloropentane. The same way, if this carbon atom had a chlorine atom attached to it, it would be called 1-chloropentane. So we are going to get 2 over here, right? And the third one is going to be the third carbon atom. So the first one is CH2, Cl, CH2, 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 CH3. This is 1-chloropentane. The next one is CH3, CH, Cl, CH2, CH2, CH3. 1, 2, 3, 4, 5. So that's 2-chloropentane. The last one is going to be CH3, CH2, CH, Cl, CH2, CH3, which is 3-chloropentane. Now, I am going to write just one more, just to show you for the fourth and the fifth as to why we're not doing it. So the fourth carbon atom, CH3, CH2, CH2, CH, Cl, CH3. Yeah, 1, 2, 3, 4, 5. So when we numbered it till now, we went from the left to the right. Okay, but that's because chlorine had to get the least number that was possible. Whereas in this case, when we need the least number, it's going to be 1, 2, 3, 4, and 5. And because of that, this is 2-chloropentane, which we've already mentioned in one of the previous, right here. So this is also 2-chloropentane. This 2 is 2-chloropentane. And because of that, this particular straight chain pentane is the answer to the second one, which gives us 3 isomeric monochlorides. So basically, all I would suggest is, if let's say they ask you to, write the various alkanes, isomeric alkanes that are giving us various types of monochlorides, what I would strongly suggest is first write the isomers and then figure out which one is going to give us a single monochloride, which one is giving 3, which is giving us 4. With that, we're done with the Intext questions for this video. In the next video, we'll be finishing up with the last one, 10.5.